Hello again, my fellow pilots and my fellow aircraft maintenance personnel. Your host is always Haitham Ali, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today, everybody, I'm going to explain an important issue regarding the Airbus A320 aircraft. Airbus A320 aircraft. It is a safety article produced by Airbus on the Safety First magazine by Airbus regarding a braking system cross-connections problem. Braking system cross-connections problem. Okay, so what is the problem here? During changing of tachometer or changing of the landing gear and rewiring the anti-skid component like the tachometer or servo valve, the maintenance people do mistake and the cross-connected cable. This problem or this mistake, everybody, result in a problem to the aircraft while landing. Okay, so the pilot will feel that the aircraft deceleration is not good and an unwanted yaw tendency to the left or right, and in the most bad scenario the aircraft stop after finishing the runway of more than 150 meters. So the aircraft go out of the runway. The aircraft leave the runway, and it was the most bad scenario. Okay. In this article, what we will learn in this article or in this session, what we will learn? We will learn the basic three components of the anti-skid system. If you ever been asked what is the main component, everybody, of the anti-skid system, you can say that it is the tachometer, servo valve, and the braking steering control unit in the Airbus A320. Again, tachometer, servo valve, and the braking steering control unit. These three components must be connected properly. Okay? Because the anti-skid system is an independent system for each wheel. And the tachometer measure the rotation speed of each wheel, comparing it with the aircraft speed in the BSCU. And if there is a high difference between these two speeds, so this wheel specifically is skidding, and the braking steering control unit will release brake pressure on that wheel only if it is properly connected. But if it is not properly connected, and this is our scenario for today, the BSCU will mistakenly release the pressure on the unskidding wheel. So the aircraft will yaw to the left or to the right. Pilot need to know that if they anytime suffer from an unwanted yaw tendency or a bad deceleration, a small deceleration, they need to as soon as possible apply the loss of braking memory item. In this loss of braking memory item, they been asked to switch off the anti-skid and the nose wheel steering switch. Switch off the anti-skid and nose wheel steering switch. In that case, the cross connection problem will be solved. Okay, everybody? Okay, so let's see the data from this article thanks to Airbus. Let's see this article on the cross connection. As you can see here, everybody, the braking system cross connection have generated a few incidents over the years. And the worst case, as I told you, experience on the Airbus fleet led to an airplane stop around 150 feet from the extended runway center line. And an emergency evacuation was initiated and everybody escaped safely. Okay, everybody? Okay. So, the cross connection happen on two levels, or there are two types of cross connection, everybody. This cross connection may happen at the level of tachometer or at the level of servo valve. What is the servo valve? It is the electrohydraulic servo valve that being controlled by the BSCU to allow the brake hydraulic pressure to reach to the brake unit. Okay, so in this article we will express the two types of cross connection reported and their consequences. Again, the two types is cross connection at the level of tachometer and the cross connection at the level of servo valve. And keep in mind that tachometer and servo valve are two main components of the anti-skid system. Again, tachometer and the servo valve are two components of the anti-skid system, plus the BSCU, braking steering control unit. So, what do you think? Is the reported event more at the level of tachometer or more at the level of servo valve? I tell you, it is at the level of the tachometer. Because at the level of the servo valve, both servo valve, everybody, are located on the landing gear shock strut. And one on top of the other. And at the level of the flange that having the connecting cable, okay, if you mistakenly cross-connected the wiring of the two servo valves on the shock strut, you will have a sharp edge giving you an indication that there is a problem now, and you may take care and rewire on the right on the right steps. Okay, everybody? So, the cross-connection event reported to Airbus are more, the cross-connection event reported to Airbus are more at the level of tachometer, more than at the level of servo valve. More than at the level of servo valve. Okay. So also we will learn the existing prevention measures. Okay. The operational procedure to mitigate them. If you are a pilot and you suffer from an unwanted yaw tendency, or a bad deceleration, you need to apply the loss of braking memory item immediately. The loss of braking memory item immediately, everybody. And finally, the improvement already implemented or contemplated. So, increased awareness on this possible maintenance error should help avoiding or mitigating further event. So, everybody, the cross-connection, braking system cross-connection is a maintenance error. Maintenance error leading to operational error. Everybody. Okay. So, let's see the type of events. Reported on the single-aisle aircraft family. Okay. Type of event is a cross connection at the level of tachometer and at the level of servo valve. And as I told you, the reported event at the level of tachometer more than the reported event at the level of servo valve. Okay. So, a few cases of main landing gear tachometer cross connections have been reported. These cross connections were done at the level of the wheel axis, as shown on next figure or figure 1. Let's see figure 1, everybody. As you can see here, this is the braking steering control unit. Braking steering control unit, or BSCU. Okay. And each BSCU connected to a certain servo valve and a certain tachometer, like the outboard wheel. This is the wiring, everybody, connected to the servo valve, left hand outboard wheel channel, connected to the left hand outboard wheel servo valve, and the left hand outboard wheel tachometer. And also the left hand inboard wheel channel in the BSCU must be connected properly to the left hand inboard wheel servo valve and the left hand inboard wheel tachometer. So this is the problem, everybody. You see here, a cross connection is happening due to maintenance error. Maintenance people mistakenly connect the left hand outboard wheel wire into the right hand oh, sorry, yes, onto the left hand inboard wheel wire, and vice versa, cross connection happening. So now the wire is not connected properly with their specific channel in the BSCU, so that if this wheel suffer from skidding, the BSCU will receive this signal, okay, and the BSCU in that case will release the brake pressure on the other wheel. It's supposed to release pressure on this wheel because it is skidding, but due to cross connection, the BSCU in that case will release the pressure on the other wheel. So the aircraft will suffer from unwanted yaw tendency, okay? And the skidding wheel will already continue its skidding. So a flat spot may be an indicative to that case, and this tire may be blowing. So you as a maintenance engineer, if you ever see a very hard flat spot on any wheel, you may suspect a cross connection at the level of tachometer or at the level of servo valve. And in the troubleshooting manual nowadays, everybody, there is an entry if you have a flat spot to examine a cross connection problem, everybody. Okay. So we see now the connection between the BSCU and the wheel tachometer and the servo valve. So each channel, specific channel in the BSCU, must be connected properly to its dedicated servo valve and to its dedicated tachometer on the wheel. Whenever a cross connection happens, this will be a big problem. And in that case, the BSCU will not solve the skidding problem on the already skidding wheel, but will release the brake pressure on the other wheel, not on the already skidding wheel. Okay, everybody. So let's see on the next figure. Next figure will show an actual cross connection on the right hand side main gear. The cable labeled 19 Golf Golf Alpha 22 Golf Golf dash Alpha connected to the tachometer, the blue cylindrical equipment, which can be partially seen on the right hand side of the picture, should in fact have been the cable 20 Golf Golf dash Alpha or 21 Golf Golf dash Alpha. You see here, everybody, this is the tachometer, everybody, and this cable connected to this tachometer, and it is a cross-connected cable. This is a mistake, cross-connected cable. Okay. So this is a picture of a tachometer cross connection. This is a tachometer. This is the wheel axis, okay, or wheel axle. And this is a tachometer, and the maintenance people do mistake by connecting the wrong cable to this tachometer, Okay, everybody. So, what is the other problem, or what is the other cross connection? The other cross connection problem will be happening at the level of servo valve. But this scenario happened only twice, or a few cases reported in that case. Because as I told you, the flange on the shock strut supported the cable to the servo valve. If you mistakenly cross-connected, you will see a sharp edge in the wire, will give you a logic indication that you cross-connected the cable. This cable must be connected to the other servo valve, not the already connected servo valve. So, as you can see here, even if only 2 cases have been reported to Airbus, it is worth mentioning the other type of cross-connections experienced so far. It involves a connection to the servo valve as shown on figure 3. You see here, this is the BSCU, everybody, braking steering control unit. Left hand outboard wheel left hand inboard wheel. So this wire, this green wire, must be connected to the inboard wheel while it is connected to the outboard wheel. And this red wire to the left hand outboard wheel must be connected to the outboard wheel, but in fact it is connected to the servo valve of the inboard wheel. So a cross connection problem happen at the level of servo valve, everybody. Okay, outboard wheel, inboard wheel, tachometer and the tachometer. Okay, everybody, the tachometer, everybody, is the component of the anti-skid system that measures the RPM of the rotating wheel okay, and the function of the BSCO is to compare wheel speed thanks to the tachometer with the aircraft reference speed, and if it suspect any wheel skidding, it must release the brake pressure on that wheel, otherwise it will blow in, it will suffer from a flat spot, and the brake performance will be significantly affected, everybody, significantly affected. Okay, so let's see a picture of a real cross connection at the level of servo valve. As you can see here, everybody, this is the shock strut, and we have here, this is the upper servo valve, and this is the lower servo valve on the shock strut. And as you can see here the flange. Okay, this is the flange supported the cable that must be connected to the servo valve, and here the maintenance people do the mistake. This cable must be connected to this servo valve, not this one, but it does a mistake and connect it to the other one, so a sharp edge will be here, an indication that there is a problem. Okay, everybody, so you see here a sharp cable bending to achieve cross connection. Sharp cable bending to achieve cross connection, thanks to the cable flange here, cable supporting flange. So by design, okay, thanks to the supporting flange, if the maintenance people do mistake of cross connecting the cable to the servo valve, they will have an indication of a sharp edge in the wire that will be an indication of this cross connection. Okay, everybody, so that, as you can see here, the lower number of cases that have been reported can be explained by the fact that the flanges supporting the servo valve cable have different lengths. These type of cross connection are thus more difficult to realize. Okay, and we see on the figure an example of servo valve cross connection. This is the servo valve cross connection, everybody. Servo valve is called, everybody, electro-hydraulic servo valve. Each wheel has its own servo valve for the normal brake and other servo valve for alternate brake, which is called alternate servo valve. Normal servo valve and alternate servo valve for normal brake and for alternate brake. Okay, so as we see in the figure, it shows that the flange supporting the cable to the lower servo valve allows an easy connection only on the lower servo valve. In this case, the flange forced the cable wrongly connected to the upper servo valve to make an excessively sharp bend. And this sharp bend, everybody, is the indication that will show you as a maintenance people that a cross connection problem is happening now. You need to take care and you need to prevent this cross connection for the servo valve. Okay, everybody? Okay. So, thank you always for your good listening. I already speak about the two types of cross connection. We can stop here for today. And tomorrow I'm going to continue this lecture or this session on the braking system cross connection. Okay, to see the mitigation for this problem and to see the maintenance solution and the operation solution for that problem. If you are a pilot and you suffer from this cross connection, what you will do? As I told you, you will know that there is a problem with the brakes by unwanted yaw tendency and a very bad deceleration rate. A very bad deceleration rate. What you will do, you will continue with the loss of braking memory item. Tomorrow we'll speak about that. So please stay tuned for my next session on brake system cross connection. Thank you always for your good listening. From Cairo, Egypt, your host was Haitham Ali, and I'm an aviation technical instructor. Thank you and goodbye.